do this. Boring. I'm not going to do this.
All right. Nice shot. There's my little man hitting the golf course. Look at that. First time ever golfing. And, oh, there's my shot. Almost a hole in one. Played so hard, I got a blister on my finger. Got a blister on my finger. Look at that. All right. So the first thing we got to do is declare variables in these questions. So what is x? What is y? And here I let the number of motorcycles. So if there's 4 motorcycles, 5 motorcycles, I'm going to let this mysterious number be x. So let the number of motorcycles be x. And I don't know why, but us mathematicians, we like to use x and y a lot. So we're going to let the number of cars be y. Beautiful. And that is always worth so many marks, just showing your teacher that, there's 2 unknowns, there's 2 things that we need to find out, number of cars and number of motorcycles. Now, we go back to the question and we try to make some mathematical equations out of the clues they give us. And there's 2 numbers that pop out at me. One of the numbers is 66 and the other was 20. Now, all the tires in the parking lot were counted up and there's 66 of them. So if we count up all the motorcycle tires and all of the car tires, or the wheels, we should end up with 66. So how do we make a mathematical equation out of this? Well, cars and motorcycles don't have equal numbers of tires. So we gotta account for this. So here's how we're going to do it. And I'll beatbox while I wait for me to push my pencil. So all of the motorcycles plus all of the cars has to equal 66 wheels. But these aren't unicycles and uni-tire cars. Okay, cars have 4 wheels. So I need to multiply the number of cars by 4 to figure out how many wheels there are. And motorcycles have 2 wheels. I don't count those tricycle ridiculous things. Okay, and so we got to multiply the number of motorcycles by 2. So that's the first mathematical equation. We're half of the way to solving this question. When you have 2 unknowns and you need to solve for both of them in a scenario, you always need 2 equations. You need 2 pieces of clues, or 2 facts. So the other fact that I'm going to use is the total number of parking spaces is 20. So there could be 20 motorcycles, but that would only give you 40 tires. And there could be 20 cars, but then that would give you 80 tires. So in this case, it's very straightforward. It's just all the number of motorcycles, x, plus all the total number of cars, y, has to equal 20. Now, all right, so when you get to later stages of grade 8 and deep in grade 9 and even 10, we learn how to graph this situation, and it's a really pretty thing, but there's just too many skills to try to lay out online right now. So I'm just showing you the famous substitution method. So substitution method kind of means that you're going to take something out of the picture and put something into the picture. So if you were to substitute a basketball player in basketball, you take out a forward and put in a forward, or you take out a point guard and you put in a point guard. You're usually putting something identical in to the slot that you're removing. So the substitution method requires two formulas, two equations, and we built those above. So we have the 2x plus 4y equals 66, and the x plus y equals 20. Now I'm going to take one of these equations and substitute into the other equation. But I got to make the connection that I was just making there is that x in both equations are the same, and y is the same number in both equations. So to do this little trick, I'm going to solve for x in that equation. So why don't we just move the y over? I absolutely hate this. You don't move things across the equal sign. It's going to mess up your brain sometime down the road. So what I want you to see algebra as is you're balancing. So it's hard to see here, but I am subtracting a y on both sides. I'm not just moving it over, I am subtracting it on both sides so that I don't make my math teacher angry. So when I do this, and I finish the algebra here, it's going to be beautiful. It's going to be x equals 20 minus y, because the y's, 1y minus 1y equals 0 y's, so we've gotten rid of the y's on the left. And now we're ready. This is kind of all set up for this substitution method. Now we're actually ready to substitute. So I'm going to take the equation on the right and actually substitute it in for the x on the left, on the equation on the left. So notice how I'm not putting in the x anymore. I'm just saying 2 something plus 4y equals 66. And because the x's on both sides are the same, okay, we're still talking about the same number of motorcycles, I am going to use what I solved for on the right, x equals 20 minus y, and put it in for x on the left. Now I'm using the distributive law, and I'm distributing the 20 into the bracket. So 2 times 20 is 40, and 2 times negative y is negative 2y. And now I'm collecting like terms. This is all algebra using letters with operation, number sense. So minus 2y plus 4y leaves us with 2y still. And remember, I don't know what's happening here. Okay, and now remember, we're not just going to move that. We want to solve for y, get it all along. We're not going to move that 40 across. We are going to subtract 40 on both sides. So when we do that, the 40 disappears on the left. And then we get 66 minus 40, which is 26. And now to get rid of the 2 in front of the y, that means 2 times y, and the opposite of times is dividing. So we divide by 2 on both sides, and I'm just going to try to catch up, and we get y must equal 13. So there are 13 cars there. And if there are 13 cars, the total number of vehicles has to equal 20. There's 20 parking spaces. So if there's 13, well, I need 7 motorcycles to fill the lot. So that's how I got x. So I solved for y, and x just kind of fell onto my lap. Now, just to check, to make sure that this makes sense with all the wheels, I do the 2x plus 4y, and 2x was 14, and the 4y was 4 times 13, so yeah, it equals 66, and I'm doing a little bit of celebrating, and because nobody's hoisting the Stanley Cup these days, let me do it. Right, Ruby?
Boring. going to do that.